7.6 is on radians, and radians is just another way to measure an angle. And some people get a lot more confused when we add these things in here, but radians definitely makes things easier when we get to formulas in higher level mathematics. Any formula that has the number pi in it, radians, makes working with pi related formulas easier. And it's why we use it. As a matter of fact, it's easier to count by radians when you start doing more than one revolution. It's really hard in degrees to go, okay, 360, add 360 to that, and you go 720, and then you add 360 to that, and you start getting to big numbers. But with radians, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. That was 5 revolutions. That's what that was. Very simple, okay? A lot easier to work with. Don't freak out with radians. Radians are just a different way to measure an angle. Okay? So if you want to know what the actual definition of a radian is, some people like to know these things, so I'm going to draw you a quick picture. Here's my picture. Here is a circle. Bam. And then what I'm going to do is I'm going to draw you a radius. That was not what I wanted. I'm going to draw you, hopefully, a radius that is blue. That looks better. Now we'll go back to there. And your radius is blue. A radian, by definition, what is 1 radian? It's when your radius and your arc length are the same distance. When this distance around the curve is the same distance as that r, then the angle formed by that angle is 1 radian. If you want to know how big that is, a radian is about 57 degrees, just under 60. It doesn't come out nice and even. Okay? And the one thing that we are going to use all the time is this one. 180 degrees is the same thing as pi radians. We're going to use that for just about every single thing that we do. That lets you know that 360 degrees is how many radians? If this is 1 pi radians is 180 degrees, 360 degrees is how many radians? Go ahead and say it out loud.
2 pi radians.
2 pi radians. Okay, that's it. That's what we're going to be doing. Where you're going to have some issues are in dealing with these fractions, because some of you do not visualize fractions the way you should. Paramu. Hi. Got it. Come back. Donovan, you're heading to the front office. Take your stuff with you. So going back to this, we have to deal with fractions. And the fractions, I don't know if I can help you with it other than to show you what it's going to look like, okay? So let's go ahead and do this. Let's do this. It says go back to worksheet 7.5, and we're going to fill in the radians for the unit circles as follows. We're going to go by pi over 4s and pi over 6s, and I'll explain. What I have on the screen is my 7.5 worksheet. And what I have on the screen here is we're going to figure out where the radians go for each of these angles. The angles are already there. The ratio, the coordinates are already written in. What we skipped were the radians. So let's start off with something simple. 0 degrees is the same thing as 0 radians. And if I were to go all the way over here to 180 degrees, 180 degrees is the same thing as pi radians. So please put pi right over here on the left-hand side. What does that mean? That's exactly, no, let me say that. That is approximately 3.14 radians. As a decimal, you already know what that is. 3.14. Some of you might even know 159 after that. Okay? Now, if I were to take 180 and cut 180 degrees in half, I would get 90 degrees. If I were to take pi and cut it in half, I would get this radian measure, which is pi over 2. 2 does not go in evenly into pi. It does not reduce. Therefore, it is pi over 2. That means half of pi. Pi, half of pi. From here to here, pi radians, half of it would be pi over 2. Now what I would like to do is I would like to go half of the 90 degrees. Half of 90 is 45 degrees, this line right here. And I want to do half of pi over 2. If you know what half of pi over 2 is, tell the person you're sitting next to, please. If you told your partner pi over 4, please raise your hand so I can see how many said pi over 4. That's almost everybody. There's about 4 or 5 people who do not have their hand up. So let me use the back of this piece of paper. If I have pi over 2 and I want to take half of it, you're multiplying by 1 over 2. If I want to do half of pi over 2, then that makes pi over 4. That's where the math comes from, okay? This angle, 45 degrees, is pi over 4. You fill that in. And our directions on this particular that we wrote down in our notes says, start counting from 0 by pi over 4s, counterclockwise, reducing even fractions. So we're going to go all the way around this thing. Okay? Here's what I mean. This angle that I'm pointing at is 0 radians. Then I went pi over 4 radians. What I want you to see when you write this down is I want you to think of the number 1 pi over 4. I went 1 pi over 4. Then straight up and down would be 2 pi over 4. Does this reduce? What does 2 pi over 4 reduce to?
Pi over 2.
That's why this is pi over 2 as well. Let's do the next one. 1 pi over 4, 2 pi over 4. Guess what goes at 135 degrees? 3 pi over 4. I'm going to go another 45 degrees or another pi over 4 with 3 pi over 4. Then I get to here at pi. Isn't that the same thing as 4 pi over 4? Yeah. But it reduces to pi. 3 pi over 4, 4 pi over 4. Then I get to 225. And what's that going to be? 5 pi over 4. At 270 degrees is going to be 6 pi over 4, but we need to reduce it. What is 6 pi over 4 in lowest terms? Write that in. Let me, I already forgot where I was, so I'm going to go 4 pi over 4, 5 pi over 4, 6 pi over 4. At 315 degrees, it's going to be the same thing as... And then adding one last pi over 4, I get to 8 pi over 4, but that reduces. What is 8 pi over 4? We're going by 45 degrees or pi over 4s every single time. Now, some of them reduce. The odd ones do not reduce. Simple. That was this step right here in our notes. It says start counting by, do the pi over 4s first. Reduce, let me underline that word because that's what we have to do. We have to reduce the fractions that are even as we go. The next ones that we're going to do are 30 degrees apart. Since you know the degrees already. 30 degrees is the same thing as pi over 6. Go back to my paper. 30 degrees is what radian? Now I want to prove that to you in one other way before I start counting. I used this young lady's quiz. Let me use it again. If I had 30 degrees is a third of 90 degrees. 30 degrees is a third of 90. So if I took pi over 2 and I wanted a third of the radian measure, that's going to equal pi over 6. In case you ever forget how to figure out what this is, just do a third of that and you'll know it's pi over 6. And now, 1 pi over 6. 2 pi over 6 is going to reduce. 2 pi over 6 reduces to what number? Let's put that in there. And we're going to keep going around the circle counterclockwise. 1 pi over 6, 2 pi over 6, 3 pi over 6 is straight up and down, but it's already written in and it's already reduced. But it should match up. 3 pi over 6 is pi over 2. 4 pi over 6 reduces. What does it reduce to? 2 pi over 3. 4 pi over 6. 5 pi over 6 is odd. It's not going to reduce. Can I go faster? 6 pi over 6. It's already there. It's already reduced. 7 pi over 6. It's odd. It won't reduce. 8 pi over 6. It's even. It's going to reduce. 9 pi over 6. It reduces. It's already reduced. It's already written down. Reduced in lowest terms. 10 pi over 6 reduces. 11 pi over 6 is our last one before we get to 12 pi over 6 or 2 pi. So now we have all the radian measures all the way around this unit circle. It's basically taking 1 pi radians and cutting it up into our nice even slices just like the degrees were. Now here's the one thing I like about radians, just in case. Let me turn that light off real quick. Can you see the reference angles in radians? Hint, look at the denominators. Let me zoom back out and turn this light back on. Look at this reference angle. Do you remember earlier we talked about the 150 and the 30 being the same x and the same y? And the 210 and the 330, because they all have the same theta prime, the same reference angles. Look at the denominators. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Only the ones that have pi over 6's have these x's and y's. Only the ones that have pi over 4's have these x's and y's. Only the ones that have the pi over 3's have these x's and y's. So what I like about radians is it's easier for me to tell what the reference angle is with radians than it is for degrees, personally. Now with that being said, we're going to jump into some examples. If you want to do these in your worksheet while we do them, you're welcome to do so. The first problem I chose for you to do is number 9. It says, draw each angle in standard position using radians. Don't convert to degrees. So the first thing I do is I draw an x and y axis. Just like before, positive angles go counterclockwise. Negative angles go clockwise from our initial ray. So if I'm going negative 7 pi over 4 radians, I know where that's going to end. It's going to end right here. If you do not know why, I will give you a reason why. Because if I go 1 pi over 4 radians negative, it'd be this way. And another pi over 4, and another, and another, and another, and another, and another. 1 pi over 4, negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4 puts me into quadrant 1. And that's it. Number 14. Number 14, I had more questions in second and first period about number 14 and how to do it. There are 3 of these types of problems. Find 2 angles in radians, one positive and one negative, that are coterminal with the given angle. So I need to find a place that ends exactly at 3 pi over 10. So as a picture, 3 pi over 10. Here's pi. Here's half of pi. This is not half of that. 3/10 is not, so it must be over here somewhere. It must be like right there somewhere. Has to be. What I need to do is find something that is coterminal with that. So in order to find something that's coterminal with it, what we have to do is we have to add a full revolution. In radians, 1 full lap around the whole circle, not half of a lap, is how many radians? We just talked about it. Tell your partner. What is 1 full lap? I hope you said 2 pi radians. 180 degrees was pi radians. 360 degrees was 2 pi radians. 2 pi. So if I want to have a positive coterminal angle, I'm going to be adding a full lap, a full revolution, which is 2 pi radians to 3 pi over 10. Well, how do we do that? You have to find a common denominator first. So what I'm going to recommend is that you take your 3 pi over 10, you're going to look at this denominator, and then you're going to say, I need to have a denominator of 10. I'm going to multiply by 10 over 10. I'm going to take this 3 pi over 10, and I'm going to add 20 pi over 10 to it. A lot of you will be able to look at this and say, is 20 pi over 10, is that the same thing as 2 pi? So really, we're just adding 2 pi to this, but we have to have a common denominator. So our first positive coterminal angle is that will put us exactly in the same spot. Because from here, if I add a full revolution, if I add 2 pi to it, I'll end in the same spot. That's 23 pi over 10. That's a positive coterminal angle. Well, I have to also find a negative coterminal angle. If I added 2 pi to find the positive one, usually we do the opposite to find the negative one, which is what? Subtract. Okay, I'm going to do this one over here. 3 pi over 10, and I'm going to subtract 2 pi. Do I need a common denominator when I do subtraction as well? Do you mind if I just change this to 20 pi over 10? What is 3 pi over 10 minus 20 pi over 10? What does that equal? That is a negative coterminal angle with 3 pi over 10. My hint to you as you do the other 2 problems that look like this, look at the denominator. You will still add 2 pi, but this changes depending on the denominator. This changes depending on the denominator. The 2 pi doesn't change. What you multiply by to get to that common denominator is what's going to change. The last two examples are 17 and 21. 17 will be easier than 21, and then we'll end our notes right there. So 17 says, draw each angle in standard position, show the reference angle theta prime in your diagram, find the measure of theta prime in radians. So start off with my x-axis and y-axis. 2 pi over 3 is in quadrant 2/3 of a pi. I know where pi is. Pi is over here. 2/3 of it will be right about there. Draw each angle in standard position. Boom. Check. I've done it. Show the reference angle theta prime. This is theta prime. The angle formed to the x-axis. We're going to have to figure out what theta prime is. What's the measure of theta prime in radians? Well, if this to here is 2 pi over 3, and from here all the way to here is pi radians, to figure out how big theta prime is, I just have to do pi subtracted by 2 pi over 3. It will be helpful for you to have this in terms of the common denominator. Don't hesitate to take this pi and multiply it by 3 over 3, so turn it into 3 pi over 3. 3 pi over 3 minus 2 pi over 3 is what theta prime is going to be equal to. What is theta prime going to be equal to? It's that common denominator that we talked about earlier. That's our answer. I can't tell you how many students who have issues with fractions don't understand what we're doing right here, so you may have to explain this to your partner if they need help. Possibly. Okay? Here's the last thing we're doing. Number 21. 5 radians. Now 5 radians, let me see what that's about. Let me go over here to this definition. 1 radian is 57 degrees-ish. 57 degrees times 5. It's about 285 degrees. Just so I kind of know where it is. I already know what quadrant that's in. This is 270. So 5 radians must be from here to here. Theta prime is the angle that's formed between this and the x-axis. So the hardest part about this problem is knowing, okay, we said from here to here is pi radians, but if I keep going, this is 2 pi radians. If I want to know what theta prime is, what I have to do is I have to take that 2 pi and I have to subtract the 5 radians from it. There is no pi with this 5. 5 is the decimal approximation of the angle, okay? So it's just 2 pi minus 5. We can't put those together. This is your exact answer. If you wanted to and actually wanted to figure out how many radians as a decimal, you could put 2 pi in on your calculator and subtract 5 from it to get the decimal approximation. This is about 1.28 radians if we wanted to figure that out. We do not have to in this problem. But I wanted to put it there just because that's what those numbers represent. We're going to stop your notes right there.